Session 18 on Python, Object-Oriented Programming in Python. What you will learn in the session is classes versus objects, attributes and methods, private attributes, documenting the classes, static methods, class attributes and methods, and understanding decorators. This session is all about object-oriented programming. What is it first of all? C++ was probably the first. I'm not very sure, but most likely, because I remember when we started working on programs, we used to work in C language, then C++ came, and that was object-oriented programming. In order to understand the concept of object-oriented programming, you need to first understand what is the other approach of programming. The other approach to programming is procedural programming, and you need to understand the problems or downsides of procedural programming in order to understand object-oriented programming. When we say procedural programming, you write procedures and functions to complete your task, to solve your problem. In this writing procedure, you lose focus somewhere of the side effects of that procedure or the function. For example, you may write a function which is using a variable which might be used by other functions as well, and accidentally you may change that variable which is not desired, which may lead to other problem. So data is exposed because there are two ways only of these variables, which example which I am quoting here, global and local. When I am using global variables, my intention was to use into one function or two functions, but unintentionally I may use the same in some other function as well. So procedure, in one line, our focus is solving the problem and going away from the side effect and ignoring the side effects of that procedural approach, which in general leads to errors in some other area of the program or some other portion of the code. In also one more point, in real life we don't deal with procedures, we deal with objects. Whatever you see around, you see objects. Pen, paper, printer, computer, anything is an object. Even in fact, we can also think about ourselves as an object. Human beings are also object, employees are object, products are object, because by definition object is anything which can be separated from the rest of the universe by means of a boundary. The boundary separated from the rest of the universe, and object have certain behaviors and characteristics. Human can behave, can take input, can take output, can send output to the outside world. They have way to communicate to the outside world by these objects. So object may communicate with the outside world by means of some behaviors or methods or properties. All these terms, properties, methods or behavior or characteristic, they are specific to objects. Every object has a specific behavior, specific characteristic or specific way to interact with the outside world, but there are some private areas also. Every object has its own private zone. Take simple example of pen. Pen will interact with the outside world by that portion through which the ink will come out and you write. But inside the pen, whatever machine, whatever components you see, they are very, very private to the pen. So there is a private zone of the object which is separated from the rest of the universe, which is not visible, which is outside world is not able to communicate with it, very private. And second, a common or public through which it interacts with the private outside world. Object oriented programming was the outcome of this more universal you can say objects, where we deal with objects in our daily life. And hence this approach of programming talks about the same behavior, talks about the same concept. It's a method of structuring a program by bundling related properties and behaviors into individual objects. So now you understand this: related properties and behaviors put together by means of a boundary, and objects are created. So therefore we can say that an object is a separate from rest of the universe, and by means of some boundary which can take some value from the outside world, which can send something to the outside world, but individually it has its own variables and functions and methods and components. So that means I can have a function which is only accessible from inside. I have another function which may be accessible by only a function inside the object. But there might be a function which is accessible from outside world. There might be a variable which is possible to set by the outside world. So there is a private zone also, and there is a public zone also. For instance, an object could represent a person with properties like name and age, and address and behaviors such as walking, talking, breathing and running. This was the main reason of introduction to this language. Not only human, you think of any object in this world, the behavior you will find same. Properties and behavior. Property refer to variable, behavior refer to function. Function is still the name given in procedural programming. In object-oriented programming, we use the term method. So they are interchangeable. To understand the meaning, function or method have the same meaning, except that method is a name given to a code in object-oriented programming. Same thing in procedural programming is known as functions. It could represent an email with properties like recipient list, subject and body, and behavior like adding attachments and sending it. So sending and adding attachment has to be a method, but properties, recipient, subject, body, behavior will be variables. So properties can be thought of as variables, and behaviors can be thought of as methods or the functions. Python has been object-oriented programming since it is existed. Because of this, creating and using classes and objects are downright very easy in Python. Classes and objects. Now you can see the definition here itself. If you have understood what I explained, I'm sure you can define the term class and the object now. Class, if I say, is a category. Object is an instance of the class. Like if vehicle is a class, bus is an object. If human is a class, Yao is an object. If employee is a class, then Dora is an object of that class. So any individual object from that category is called object. So category is a generalized method. Specifically, if we talk about that, will be object. Let's understand these terminologies. Class is a user-defined prototype, as I said, prototype or the category for an object that defines a set of attributes that categorize any object of the class. The attributes are data members. As I said, properties or attributes are variables or data objects. So class variables and instance variables. And methods. Method means the functions accessed via dot notation. Class variable, a variable that is shared by all instances of a class. Means, like if I say name is shared by all human beings. So human is a class, name, every human will have a name, mandatory. Bus will have vehicles, or bus is an object of vehicle class. If vehicle is a class, then bus is an object. So every vehicle will have wheels. So I can say the wheel is that variable, because all instances of the vehicle class will have wheels. We can't have vehicles without wheels. Class variables are defined within the class but outside any of the class methods. Within the class you define them. The class variables are not used as frequently as instance variables. Then data member, a class variable or instance variable that holds the data associated with the class and its objects. Means inside the class, if you define a variable to hold the data associated with a class, is called data member. Instance variable, a variable that defined inside a method, means the function, means the programming logic. So instance variable is a variable that is defined inside an object and belong only to the current instance of the class, meaning they are very, very specific. They are very specific to the object of a given class. So specific property, if I define, like how a bus travel, and I define a method and I define some characteristics of traveling, when the bus moves, that will be an instance variable. Define some characteristics of vehicle. For example, a diesel tank or CNG tank or petrol tank is applicable for bus but not cycle. Bus, we have to specify how the bus travel, how the bus moves, but cycle have a different way. So there are some characteristics which are applicable only for bus but not cycle, but both are vehicles. So depending on what is so specific about that object, if we have some characteristics which we changed in a function, which we use in a function, or right word, I'm going to use the term method. In a method, very private to that object, not for other objects, applicable for other objects of the same class. That is instance variable. Inheritance, transfer of characteristics of a class to another class that are derived from it. If vehicle is a general class, superclass, then I can drive another class to it. Two-wheelers, four-wheelers, three-wheelers, all are vehicles. So if vehicle is a general class or superclass, then two-wheeler, three-wheeler, four-wheelers are derived classes. If employee is a superclass, then manager, supervisor, team members are derived classes. We can have organization. Think of any human behavior or real world scenario, you will find these examples in any scenario, any walk of life. Instance is individual object of a certain class. An object, obj, that belongs to a class. Circle, for example, is an instance of the class circle. Method, as I said, method is what? Is a function. Define a method in a class by including function definitions within the scope of the class block. Interesting point here is only one, that method is visible inside the class or applicable only for that class. There must be a special argument, self, in all method definition which get bound to the calling instance. There is usually a special method called init in most classes. Object, a unique instance of a data structure that is defined by its class. An object comprises of data methods, data members, that is class variables and instance variables, and methods. Now the complete definition of object, as I explained. An object consists of class variables, means variables that are specific to the entire class, which are common to the entire class, and then there are variables which are specific to the methods of this object. So object consists of these class variables and instance variables and the methods. Operator overloading. Overloading, as the name suggests, plus sign is basically for adding two numbers or adding integers. What if I make this plus sign do some extra work? I'll give a different meaning to this operator. That is called operator overloading. Any operator which is doing extra work apart from the designated work, apart from the meaningful work which is already known for, that is called operator overloading. In fact, we also have something called as function overloading. A function which performs some extra work or other work apart from its common defined work is called function overloading. How do we create classes in Python? Classes are created in Python by using the term keyword class. Attributes are variables that belong to a class. Attributes are always public and can be accessed using the dot operator. For example, my class dot my attribute. Think of these attributes as variables only. The name of the class followed the keyword class followed by a colon. So for example, class student colon, this is a here document, definition, this is a method or the function of the class student, and as I said, init is always the first method we normally define. So init, self and a, these are the two variables I am passing, n and a. Self dot full name equal to n, self dot age equal to a. So this is a self dot full name, means the initial values, initial two variables are defined. One is full name, second is age, and the initial values are passed by the calling program which is initializing. So first name will be n, age will be a, and then this is initializing it, this is setting the values. We write another method here, get age, self, and so therefore it will return self dot age. Similarly, we can write another method, get name, and self dot name should be returned by that. This is a simple syntax of creating classes in Python. We'll understand the meaning and then we'll create an example, then we'll do one example. Let's understand one by one. The term init was used. Init serves as a constructor for the class. Usually does some initialization work. Constructor by definition is something which is automatically called. Like the moment you think of a human, you come out with a image of a human, that okay, human look like this. So that is default self-explanatory thing or inherited thing or built-in things. So constructor which will construct, which will give the initial skeleton, initial value is known as constructor. The argument passed to the class names are given to this init method. So the init method for the student is passed Bob and 21. The new class instance is bound to this. So this is how we define B equal to student, and we are passing Bob and 21. So the name will be Bob, age will be 21. These two variables will be assigned by means of constructor, because automatically it will call that init function because it is constructor. So Bob will go to n, and because self is defining, that is initializing this class itself. Whenever you define an object, it will initialize with whatever value you provide here. So Bob 21, so here name will be Bob, age will be 21. So when we are passing Bob and 21, this is how we can initialize object of this class. So because class name was student, so B is an object of the class student with name as Bob and age as 21. The init method can take any number of arguments. Like other functions or methods, the argument can be defined with default values also, making them optional to the caller. However, the first argument self is special. We use the self means whenever you create any object of this class, this self has to be there. This will tell that I am initializing myself as an object by putting the value specified by this method. If not, I can use default values also. The first argument, what is the importance of the self? We need to understand this a little more. The first argument of every method is a reference to the current instance of the class, means the current object. Meaning when you are initializing, you need to reserve some space, you need to reserve some data, you need to put something. So that self refer to whenever you create any object of a class, you use self to define that. By convention, we name this argument convention, not a rule. It is self. In init, self refer to the object currently being created. So in other words, in other class method, this refer to the instance whose method was called. Although you may specify self explicitly when defining the method, you don't include it when calling the method. Defining, we use it. When calling it, we don't use it. Python passes this for you automatically. For example, we are defining the method, this class inside the definition, and we are defining it define set age self number, and we are self.age equal to number. But when we are calling it, we are using x because we are creating an object x. We are calling the method set underscore age, and we are passing 23. So we are not specifying self here, though we specified it while defining. So self refer to the current object, current instance of the class. So we don't pass it when calling it, we pass it when defining it. Now this is another example to make the concept a little more clear. Class employee, common base class for all employees. Employee count 0. Defining init self name salary. So self.name equal to name, self.salary equal to salary, and employee count, employee.emp count is incremented, plus equal to 1 means increment. So this way, what is happening here? Interesting point. What it is doing, we are defining, we are creating an instance of the class. Whenever we create an object of this class, we'll be creating instance, and the moment we create an instance, obviously our employee count will increase, and this is a private variable. Very interesting point here, a new concept comes into is a private variable. So this private variable or attribute will be incremented every time you create an object, and this is available inside. You can extract it anytime. So this is how define display count. You can call it total employee %d employee.emp count. Define display employee self. You are defining that you are displaying name and salary. The variable employee count is a class variable whose value is shared among all instances of this class. This can be accessed as object name dot variable name from inside the class or outside the class. You declare other class methods like normal functions, with the exception that the first argument each method is self, as we have discussed earlier. Python adds the self argument to the list for you. You do not need to include it when you call that method using that object for that object. Creating instance objects. To create instances of a class, you call the class using class name and pass in the argument init method accepts. So this would create a first object employee class like employee 1 employee Zara 2000. This would create second method, second object of the class employee 2 employee money. How can we access them? We can access these using, you can access the objects attribute using the dot operator as we discussed earlier. So employee 1 dot display employee, employee 1 dot display employee, display count, so we can see the count also, employee total employees, employee dot employee count. So employee count is a variable or attribute, employee is the object, so we are displaying the count of those employees. Now this is a complete program putting it all together, what we discussed. Class employee, let's go and check this program directly on the system. So this is Python 1, first program. Class is employee, common base class for all employees, employee count, define init, name and salary, and whatever you pass, name will be placed here, salary will be placed here, and employee count will be incremented. Define self count, display count, so total employees, and then print display employees, name self dot name, salary self dot converted into string because salary is in a number, so we need to use typecasting, we call it as casting. So string of salary, and then we are initializing the object. This is first instance created, or the first object created of this class. This is employee 2, this is second object created, and now we are displaying. So what we expect both the employees should be displayed and the total number of employees should be displayed at the end. Let's try to execute it. So this is first employee, name Zara, salary 2000. This is second employee, name Money, salary 5000, and total employees 2. This is how object oriented programming works in Python. Let's look at another program, python2.py. What is happening in this program? Similar program, class employee, base class, employee count 0, and initializing up to here, no problem. Displaying it, display count self, total employees, number of employees we are counting, and then we are displaying them together. But what I want to understand is some characteristics, some special values. The document, the name, the module, the base, the dictionary, what these terms are, we will understand them. But let's fetch the value first. Employee.doc, these are implicit special attributes, and you will get the value using this object. Employee is the object, dot the attribute value, and let's see what these values are. These are very, very specific. Every time you create an object, you get these attributes, special attributes, and you can fetch the values. Let's try this. So employee.doc, meaning the comment part of it. Employee.name means the name of the class. Employee.module means the main module. The base means the class object, the value. The dictionary means whatever you used inside your class, you get everything. So you can get the data or statistics, the details about your class by using this special built-in variable. Now this program is done. Output, we have seen that you can add, remove, add attributes to the class and object anytime by passing this. Two kinds of attributes are there. The non-method data stored by objects are called attributes. Data attributes and class attributes. Data attribute means variable owned by a particular instance of a class. They will store the data. Each instance has its own value for it. That is data part of it. Each instance will have a separate value. These are most common kind of attributes. But there are some common properties as well. We call them as class attributes or class variables. Attribute or variable is one and the same thing. Don't get confused, because initial first slide we used variables, but concept is same. There is no separate term, so we use class variable or class attribute is one and the same thing. So class attribute owned by the class as a whole. All class instances share the same value for it. They are also known as static variable in some languages. So the static attribute is basically which is common to all objects. And if you correlate our previous example, the number of employees, the employee count was shared by all employees. I mean all objects of that class. Therefore that was static variable. So class-wide constructs, this is good for class-wide constructs, the class attributes or class variables or static variables. And second, building counter of how many instances of the class have been made, and that is what the example was used in our case, counting how many employees have been created so far. Data attributes, look at the examples now, both cases one by one. Data attributes are created and initialized by init method. Simply assigning to a name creates an attribute. Inside the class, refer to the data attribute using self. For example, self.fullname, like class teacher, a class representing teacher. Init self n, so full name equal to n. Print name self, so self.fullname, printing it. So they are data attributes. They are defining inside the instance of the object when you create them. They are not common to the class. The class attributes, because all instances of a class share one copy of the class attribute, when any instance changes it, the value is changed for all instances. And that was when we added employees and when we fetched employees. But if you want to understand them separately, then this example is good. Class attributes are defined within a class definition and outside of any method. That's the only difference. We define these static attributes, we define these class attributes outside any method. Since there is one of these attributes per class and not one per instance, they are accessed via a different notation. And the notation access class attributes using self.classname.name. So underscore underscore class is to be used and then name notation. This is just one way to do it and the safest in general, like x is 23 outside this body, outside this method. So this x is a class variable or class attribute or static attribute, and then we want to fetch the value. So a equal to simple, we are calling the simple, then incrementing, but we want to fetch the value of this class, this variable x. So this is how I use it, a underscore underscore class dot x. This is the notation to fetch these attributes, static attributes, individually. Accessing attributes. Instead of using normal statement to access attributes, you can use get attribute, object name, and the default if you want to access the attribute of the object. Has attribute to check whether it has an attribute or not. Set attribute, setting the attributes. Object name and attribute to set an attribute. If the attribute does not exist, then it should be created. And delete attribute, delete an attribute. Take an example. Has attribute employee 1 age. Do this object employee 1 has the attribute age. Return true if the age attribute exists. Similarly, get attribute age. Return the value of age attributes. Set attribute employee 1 age. This is 8 value. So set the attribute age at 8. So delete attribute age. So we can separately manage these attributes, access these attributes, check the attributes using a set of functions which are get attribute, has attribute, set attribute, delete attribute. These are implicit functions and inbuilt methods which can be used. Similar to the method which we use to get the metadata about the attributes, built-in attributes. These are built-in class attributes. As I was given, the second example was about this built-in attributes. Every Python class keeps following built-in attributes and they can be accessed using the dot operator like any other attribute. Dictionary. This is a dictionary containing the class namespace. Doc, the class documentation string, or none if it is not defined. Name, class name, module name, in which the class is defined. This attribute main is in interactive mode. Then base class, possibly empty tuple containing the base classes in order of their occurrence in the base class list. This is example. I have just explained the same example. We have seen that example 2, Python 2. So we printed all the built-in attributes and we saw the outcome here, and this was the output of this. Destroying object is garbage collection. You don't need to do anything. It is automatically done by Python. Python delete unneeded objects automatically to free the memory space. The process by which Python periodically reclaims blocks of memory that no longer are in use is termed as garbage collection. Python's garbage collector runs during program execution and is triggered when an object's reference count reaches to 0. An object's reference count changes as the number of aliases that point to it changes, and it increases when they are assigned a new name or placed in a container. This count decreases when it's deleted with the del command. Its reference count is reassigned or its reference goes out of scope. When an object reference count reaches to 0, Python collects it automatically. It's like managed like a stack of plates. Look at this example, the counter. A equal to 40, it creates an object. The value is 40. B equal to A, decrease the reference count of this 40. Increase, we are setting a value. Increase the reference count of 40. Why? Because you are saying B is assigned the value of A, so it is referred to A only. So the value of B is 40 only. So it is reference count is increased here. C equal to B, increase the reference count of 40 once more. So initially 1, 2, 3 counters are increasing. Delete A. Oh, okay, A is deleted, so reference count is deleted. So delete the reference count of this 40. That means we are left with 2 now. B equal to 100. Again, the B is assigned a different value now. So therefore, reference count is decreased because now it is value is 100. Now we have replaced it with another object, another value that is 100. So the reference count is decreased here. And C0 equal to -1. Again, we are changing the value. So we are decreasing the reference count. The counter has reached to 0. Therefore, this will be collected now. You normally will not notice when the garbage collector destroys an orphan instance and reclaims its space. But a class can implement the special method which is __del__ called a destructor. The way we have constructor, we have destructor also. That is invoked when the instance is about to be destroyed automatically. You can call it manually also. In C++, we call these destructors manually. This method might be used to clean up any non-memory resource used by an instance. This is example. Class point, initialize it, delete. This is the destructor defined explicitly. Class name is self.class.name and print class name destroyed. We are displaying that okay, this class is destroyed, because that is when you delete the pointers. When you create the pointers, so you are creating a pointer here, specifying the values of the pointer, you are printing the value, and now you are deleting. The moment you delete the last point, point 3, you will get a message, it is destroyed, point destroyed. This is the output of this. This is destroyed or destructor being called after all the objects of the class are deleted. Class inheritance. Instead of starting from scratch, you can create a class by deriving it from existing class by listing the parent class in the parentheses after the new class name, which essentially means, as I was talking about, manager, employee. So employee is a super class, and I can derive a class, I can create another class manager out of this employee, because manager is also an employee. So whatever common characteristics are, they will be for employee, and any specific thing for manager, they will be specific to manager. So the child class inherits the attributes of its parent class, and you can use those attributes as if they were defined in the child class. A child class can also override data members and methods from the parent means you can give your own meaning to a given method in the child class. The method which has a different function, different object, different meaning in the parent class. Override, you can override them. Derived classes are declared much like their parent classes. However, a list of base class to inherit from is given after the class name. So we are defining a subclass or the child class, class name, parent class 2, and then we specify our own class additional things also, and then we specify the code part. This is example, which is example number 4 in your source code, that is defined derived classes or inheritance. So here we see we are defining a parent class, parent attribute 100, initialize function, parent method self defining calling parent method, set attribute setting the attribute, get attribute getting the attributes, and then child class which is derived from parent. We are writing here class child drawn from parent. Define the child class. It has its own initialization method calling the child class. Define child method, this is calling child method. Functionality, we are not focusing on the functionality here, we are just trying to understand the scope. Now we create an object C of the child class. So instance of child is created. C.child method, the child calls this method. Child method means you will get this method calling child constructor, because this is the method which is called here in the child, calling child constructor. Then C.parent method, we are calling the parent method from this. So parent method is by default, this is calling parent constructor, so you will get the parent calling child method, then calling parent method. Because here we are calling all the method, child method, so first its constructor will be called, then calling child method will be called. So first step, when we say call child method, when we say C equal to child, the constructor will be called, right? Child method will be called, this one. So first, whenever you define, the constructor will be called, that is child constructor. Second time when you are using child method, this method is called, that is calling child method. Then calling parent method, the moment you say parent method, then parent method will be called. So calling parent method. And then set attribute 200, this will set again the parent's method. And then get attribute will get the parent's method. So you will get the parent attribute 200. So this is what the example of a parent and child class example. We can have a class created or derived from existing classes. That phenomena is called inheritance. So the derived class, now you understand. Similar way you can derive a class from multiple parent classes. Like you define class A, define class B, and define class C based on class A and class B. That is called derived class, or same thing, derived from multiple classes. Relationship between the two classes. You can use is subclass or is instance functions to check the relationship of two classes and the instance, because sometimes you need to just verify, is this class a subclass of this particular class, is this class a superclass or instance. So you can use this is subclass. So you give the subclass name and superclass name. This function is a Boolean function. It returns true if the given subclass sub is indeed a subclass of the superclass super. The is instance object class Boolean function returns true if object is an instance of the class and or is an instance of the subclass of a class. Overriding methods. I told you that we can override operators, we can override methods also, meaning giving a different meaning to the method. And let's try understand that different meaning. We are defining a method in the parent class, my method. We are defining my method in the child class as well. So this method will override this method. So when you say C.myChild, this is instance of child is created. So when you are using C.my method, then my method will be called from the child class, which means calling child method. This will be the output, and hence you can see the output here, calling child method. That is the overriding methods. Base overriding methods: method, description and sample call, init, self arguments, constructor with any optional arguments. Sample call is object is equal to class name and you pass the arguments. Similarly, delete, that is destructor, delete an object. Sample call is delete object. So when you delete the object, destructor will be called. When you initialize an object, constructor will be called. We call them as constructor or initialization and destructor as so in typical object oriented programming, the terms are constructor, destructor. Then evaluation, string representation, simple call, representation object, printable string representation, object comparison. So these are some base overriding methods which can be used in Python. Similarly, we can overload operators. Overload, as I said, the meaning of overloading is what? Putting some extra work, giving some extra job to the operator, which normally it would do. Like plus sign, as we know, can be used to add integers. What if I want to use plus sign to add to coordinate geometrical points? What if I want to make this plus sign to add to imaginary numbers? What if I want to use this to do calculations of time databases or time specific time category of date time data? That is operator overloading. Suppose you have created a vector class, same thing, vector class to represent two-dimensional vector. I give example of coordinate geometry. Vector is also same thing. We have two-dimensional data. What happens when you see plus operator to add them? Normal plus operator will not work. So most likely Python will yell at you. So how you could, however, define add method in your class to perform vector addition, and then plus operator would behave as per expectation. And this is a very simple example of this operator overloading. So class vector, initialize, self A equal to this, B equal to this, define string self vector, we are displaying the value, but this is the operator overloading. Add, self other. So what you are passing is return vector is A plus A, B plus B. So you are adding the two coordinates, you are adding the two points. So V1 is vector 210, V2 is vector 5 and minus 2, and you print V1 plus V2. So it will print 7 plus 8. So that's what 7 and 8. So that is a vector addition or the operator overloading. You can overload any operator with this method. With subtraction also you can overload. This is one example of operator overloading. Data hiding. The object's attributes may or may not be visible outside the class definition. You need to name attributes with a double underscore prefix, and those attributes are then not directly visible to outside world. So very interesting. Only difference is you just put double underscore. Then this will become secret. This will not be visible outside. You cannot call it. So when you try this counter secret count, you will get error. This will not work because you cannot call it, is not available outside the class. You are defining object, you are calling the method, but this will not be visible. This will throw error. This will return as expected. So if you try to run it, the first values, two values are displayed, but the third value is throwing error. This is not done. Secret count cannot be displayed. Python protect those members by internally changing the name to include a class name. You can access such attributes as object dot underscore underscore class underscore class name underscore underscore attribute name. If you would replace your last line as following, it will work for you. Print counter class just counter secret format. So you have to put these things in your call, and then it will execute the code as expected. Otherwise they are not visible to you. Then decorators. Decorators allows you to wrap another function in order to extend the behavior of the wrapped function without permanently modifying it. Means you are changing the behavior of a function. You are changing the job done by a function by giving other functionality. You can extend the behavior of the wrapped function without permanently modifying that function. In decorators, functions are taken as arguments into another function and then called inside the wrapper function. So for example, this is a special notation here, @GFG. This is a decorator. GFG decorator is callable function. We will add some code on the top of some another callable function, hello decorator function, and return the wrapper function. Like this is our hello decorator function. Print GFG. The above code is equivalent to specifying that hello decorator and print this GFG, and hello decorator equal to GFG decorator, hello decorator. Let's understand the meaning of this example with the help of one complete example that will clarify, that will make it clear absolutely. This is function number Python 8 program in your source code. Define hello decorator is a normal function. Inner one is a wrapper function in which the argument is called. Inner function can access the outer local function like this case function. So define inner and return inner one. And this is the function to be called inside the wrapper. So function to be used, the actual function, this is the inside the function. Passing function to be used inside the decorator to control its behavior. And this is function to be used equal to hello decorator function to be used. So we are passing function as a decorator, function as a argument, and then we call it, calling the function to be used. So you will get this example. If you try this example, hello, this is before the function execution, this is inside the function, and this is after function execution. So decorator is putting extra code, wrapping the body. Let me put it this way to give a visual representation. This is my function, this is a job done. This is function doing, function F1 is doing this work. I want some extra work to be done by this function. This also I want to include, or additional work here also. I want some work to be done before, or I want to do some extra work by this function after, or both. So let's assume this example. So what I'll do is I'll create a decorator function which will be wrapper function for this function. So this function will be passed as an argument. So this decorator plus this both will be displayed. Both jobs will be done by the decorators. That's a use case of decorators. That's all for this session. Thank you very much.